One vulnerability type on the OWASP top 10 is using components with known vulnerabilities. So I thought it would be a good idea to sort of discuss the idea of web pages like Cbe Details, which can tell you a lot about products and what kind of vulnerabilities exist in them and give you some insight in towards how they can be fixed. And in that, we'll also discuss a bit about Cvss scores and discuss how vulnerabilities are scored to determine how severe they are, as those will all be very valid pieces of information towards using components with known vulnerabilities. So Cbe Details is a web page that can be used to find vulnerabilities by product types or open source software, for instance. And this is just one that can be used. There's a lot of different ones that exist out there. I know NIST is a really big one as well that can be used to look up Cve Details as well. So as an example, we can type in a product that we want to look at. So for instance, we could say like Apache Tomcat. And what it will do is it will show us details about that product and what vulnerabilities exist. You can see over the years what types of vulnerabilities were actually disclosed inside of the product itself and the different types of vulnerabilities that exist. You'll get a lot of different insights towards the vulnerabilities. And by going into these, you can determine, for instance, we can say in 2019, we can see all the vulnerabilities that happened in 2019 and which versions they apply to. So you can see that you can get a lot of good information about that sort of detail on the source component itself. So when we're deciding whether or not to use like one open source software over another or one framework over another, it's always a good idea to check out how many vulnerabilities have been reported and how many exist inside of that software. We don't want to use components that have known vulnerabilities as much as possible. It's not really going to be possible to avoid that when you're using open source software because there's always going to be new vulnerabilities coming out. So we just have to be able to keep consistently updating those components every single time that the vulnerabilities actually come out, so that we can make sure that we're sort of ahead of the curve and ahead of the attackers. Now, these sort of vulnerabilities happen a lot, and because of that, it can be very hard to manage open source software to make sure that it's up to date. So you see these vulnerabilities a lot. A lot of companies have these vulnerabilities in their software, and a lot of famous hacking incidents are related to these sort of open source vulnerabilities, these things that are well known about by other people, because the reason being is because if a vulnerability is really well known about, there's more of a likelihood that people will create proof of concepts, which makes it easier for people to be able to exploit the vulnerabilities themselves. It also is possible that things like Metasploit will create modules for them to allow automated exploitation of those components. So you want to have a good idea of what kind of things exist inside of your product. And there are ways of like automating this. There are different like news sources that you can take a look at to be able to automate this sort of information. But in general, you just want to be keeping an eye on these sort of things to get an understanding of them. So one other thing that we want to take a look at is like Cvss scores and understanding what those really mean to us. So for instance, if I go into 2018, you'll see that all of these have a score, and it's a score that ranges from 1 to 10, where 10 is the most critical and 1 is the least critical. And you'll see each of these have like a varying range of criticality, essentially, or high scores, right? So for instance, if I pick like one of these, say the highest one here, the 7.5, when we load this CVE, we're going to be able to see details about like what sort of components are affected by it, what versions are affected by it. You'll be able to see how we come to these sort of scores. So you'll see here, when we're taking a look at the impact of the vulnerability, that's how we're essentially scoring out these vulnerabilities themselves. So we're taking a look at the impact of confidentiality, so the ability to disclose information that is not supposed to be seen by other people. We're taking a look at integrity impact, which is modification of files on a system, and then availability impact, which is the ability for other people to access that component. And then we also take a look at the complexity of the attack. So it could be like low or high. Low means that there's very low skill required to exploit it. There's like automated processes. It works every single time. Higher things that maybe don't work every single time. You have to do a bit of trial and error. They have a higher complexity to them. We want to take a look at whether authentication is required. So if we need to authenticate to a server, for instance, to be able to do an exploit, it has a higher bar of entry than just being able to do it without any sort of authentication. We also take a look at how the exploit can be accessed through like what type of vector. So it's things like network, for instance, which can be done just like over the network from anyone who, just happens to be able to see the server. There's like adjacent networks, which are people who are on a network that is in like sort of the same sub network or in the same sort of general area. And then there's like local attacks where you have to actually be on the system, and then physical attacks where you need physical access to the device itself. So those will each have different levels of severity to them, and there are different calculators that you can use to calculate these Cvss scores. The Cvss scores are very helpful because they allow you to be able to express risk in a way that is known by everybody. When we report vulnerabilities to people, we typically want to use the Cvss scores so that they can get a better understanding of how critical this vulnerability is without us needing to sort of express it in words. We can express it in this score instead, and it makes a bit more sense. So you can see here all the versions of Apache Tomcat that are affected by this specific vulnerability. And then from here, you'll also have your description of the vulnerability itself, which is here. It will show the version ranges that are affected, which will tell you in turn if you're off one of those versions, you aren't going to be affected. So it tells you essentially what you need to update to be able to fix this vulnerability. And then as well, there's a lot of different information that we can see here. A lot of these references are going to be different people that are talking about this. So for instance, you'll see that Red Hat has an entry on this. Red Hat is the Linux distribution, so they come packaged with Tomcat, so they'll have their own release on this sort of vulnerability, right? So everyone will have all these different releases on these vulnerabilities. So this is a really good place to come to learn about vulnerabilities, understand the vulnerable components that might exist on a system, and understand what needs to be done to fix them. So yeah, in general, using components with known vulnerabilities can be relatively easily mitigated by working with web page like Cbe Details to get an understanding of what components are vulnerable, what vulnerabilities exist, and then making an assessment based on the criticality of those vulnerabilities, whether or not you need to patch to the newest version. You also get details about like what situations the application is vulnerable on. Some descriptions are better than others, but this will give you a general idea of whether or not you're actually affected. So sometimes it might not, only work with Apache Tomcat. For instance, this one says the default settings of the CORS filter. If you aren't using the default settings, it means that you might not be vulnerable to this. So that's the general sort of idea. So you need to do a little bit of assessment and a little bit of work. And in general, really the best way to avoid these types of vulnerabilities is to just keep your open source software as up to date as possible. So although this can cause conflicts with functionality, in the end, it's very worthwhile because it will help you avoid security risk. So this gives you a bit of an idea of what vulnerable components might exist and how you can sort of look up details about a specific component to see if vulnerabilities exist for it. And from this, you'll be able to see information about vulnerabilities for your products and be able to update them so that you won't be exploited with these known vulnerabilities.